Okay, so we are going to start the third lesson today. So it's mixtures. Uh, Normally, in our day-to-day life, we are mostly experienced with the mixture, not the pure substances. අපිට day-to-day life එකේදී ගොඩක් වෙලාවට හම්බෙන්නේ mixtures. කියන්නේ අපිට pure substances හම්බෙනවා ගොඩක් අඩුයි. Mostly some elements like gold and iron, except all of those metals and all the things like elements, always we have mixtures. As an example, you can see in these images, there are some salads. So they contain different types of fruits and different types of vegetables and other things. That means they are not pure substances, they are mixtures. So today our lesson is to learn about these mixtures. Actually, in this lesson, we are going to learn about the composition of the mixtures. කියන්නේ mixtures වල තියෙන්නේ මොනවද? And then what is the composition? කියන්නේ as a fraction we can express what is the amount of particular substance in a mixture. කියන්නේ දැන් if we think about this salad which is in the top of the slide, it has some blueberries and then oranges and some grapes. In that way, there are different parts, different components in a mixture, and they are in a particular amount. To a total amount of the salad, a particular fraction, a particular part, ඒකේ තියෙන fraction එකක් අපි ගත්තාම එකකින් එක්තරා භාගයක්, ඒ කියන්නේ fraction එකක් වෙනවා this one kind of a fruit. So in this lesson we are going to learn about those compositions in this lesson. And then again, in this kind of a mixture, I told you that there are different components. So sometimes we want to separate those components. දැන් මෙතන නම් salads වල අපි components වෙන් කරන්නේ නැහැ. But sometimes we have some mixtures to separate the components. So we have to use different methods so to separate those components. So in this lesson, we are going to talk about those separation methods too. ඔන්නොච්චරයි මේ lesson එකේදී අපිට කතා කරන්න තියෙන්නේ. ගොඩක් තියනවා වගේ පෙනුනට ඔය චුට්ට විතරයි කතා කරන්න තියෙන්නේ. So here I am moving to the next slide. There are some mixtures here. Those things are very familiar to us. First one is concrete or a cement mixture. We are preparing this kind of a cement mixture by adding cement, sand and gravel together. Stones and also sand and some amount of cement is added together and combined with water and mixed together. Finally, we called it as a mixture of cement mixture or a concrete mixture. අපි එහෙම කියනවා at the end. Then it has few components. But these components are not just added. නිකන් අර අපේ මේක mix කරන කෙනාට ඕන විදිහට නෙමෙයි mix කරන්නේ. It has a particular proportion. It has each and every component of this mixture has a particular composition. ඒ කියන්නේ cement මෙතන අපිට දැන් පේනවා one part and two parts of sand and three parts of gravel are mixed together and combined with one. Here there's a big one bucket of water. I think each and every component has a particular amount, has particular fraction. So we call this as the composition of the mixture. Composition එක මොකක්ද කියලා කියනකොට අපි කියනවා one part of cement in that way. So this is a cup of milk. It's a glass of milk and this is a glass of a particular fruit juice. එතකොට ඔය දෙක හදනකොටත් we are not just studying. Sometimes we take 1 spoon of sugar and 2 spoons of milk powder and a cup of water in that way. So that makes our tea, or that makes our milk. And then fruit juice, we are adding 2 lemons and 2 spoons of sugar and a cup of or a glass of water. In that way, it makes our fruit juice. And this given example, which is given here, is a granite, it's a rock. When you closely look at a rock, you will see that there are little different type of colors in it. Little grains are there. ඒ කියන්නේ චූටි පුංචි granules තියෙනවා එක එක පාට. ඉතින් අපි කියනවා those are the minerals combined together to make that rock. So that rock has a particular composition. So it's a mixture. It's not just a pure substance. In that way, we have to we have to observe different types of mixtures in our day-to-day life. And we have another few examples. So I'm going to move with these things. Okay, then before going to the and I think you have understand now what's a mixture is. Mixture එකක් කියන එකේ නිකන් general idea එකක් දැන් තියෙනවා නේද? Isn't it? Hindi, Sydney?
Yes, teacher.
Oh, it has few components and they are mixed together in different proportions. කියලා දැන් අපිට පොඩි idea එකක් තියෙනවා. So we are going to further learn about these mixtures. ඉතින් අපි කරන්නේ we are taking some naphthalene. That means naphthalene balls. We are having those things in our home. අර කපුරු බෝල කියන පුංචි බෝල සුදු පාට. ඒ ටිකක් ගන්නවා. Then we are taking some hydrated copper sulfate. ඔය දෙකම අරගෙන හොඳට mortar එක දාලා පිසිල් එකකින් we have to grind it well. After that, we will obtain a mixture of naphthalene and hydrated copper sulfate. We can differentiate in that mixture. We can't take naphthalene and we can't take hydrated copper sulfate to either sides. All are well mixed. ඔක්කොම හොඳට mix වෙන we have ground them together. ඊට පස්සේ අපි කරන්නේ we are going to separate those components because we want to learn about a mixture correctly. ඇත්තටම mixture එකක් කියන්නේ මොකක්ද කියලා අපි ඉගෙන ගන්නයි මේ experiment එකෙන් යන්නේ. So here what I first do is the mixing of naphthalene and hydrated copper sulfate together to make a good mixture. So then what I do it, I'm adding some water to that mixture. Then after mixing that mixture in that water sample, I will get a blue color solution because hydrated copper sulfate easily dissolve in water. It easily dissolve in water. We all know that copper sulfate is blue in color. අපි චූටි කාලේ නම් දන්නවා copper sulfate blue color. Water වල dissolve වුණාම. So we can think that copper sulfate is dissolved in water. And we can see some white color powder at the bottom of the beaker. ඒ කියන්නේ then copper sulfate dissolve වෙලා එහෙනම් at the bottom naphthalene should be settled down. Then we are going to separate those things. What we do here is we take a filter paper and make a cone of that. අපි filter paper එක අර cone එකක් වගේ වෙන්න නවනවනේ. නවල ඉවර වෙලා අර funnel එකට දාලා we are going to filter that solution. Actually that's a mixture. We are going to filter that mixture. Then we will get a filtrate. ඔන්න word එක filtrate. What we filter through a filter paper or a funnel is named as a filtrate, which is come to the bottom of the beaker. It's a filtrate. And then on the top of the filter paper, which is on the funnel, we collect some residues. අපිට චුට්ටක් ඉතුරු වෙනවා අර ෆිල්ටර් පේපර් එක හරහා යන්නේ නැති ඒක through යන්න බැරි particular component. That component is named as the residue. ඕනම වෙලාවක if we are filtering a solution, what we collect on the top of a filter paper, on the top of the funnel, is named as the residue. Residues. There are many residues. We don't know what is it is actually. There are many. So we call it as a residue or residues. And then what we collect to the beaker is the filtrate. That is the liquid part of the solution. That is filtrate. We call this process as the filtration. ඉතින් එහෙනම් මේ මික්ස් එකේ අපි දැම්මේ දෙකයිනේ. So what is collect as the residue is naphthalene. It is not dissolving in water. And what is dissolved in water is copper sulfate. So we have separated that now. Mixture which was at the beginning, now we have separated all the components in it. What we use, the method I use here is filtration. So it is not a chemical process, just a physical process. අපි නිකම්ම ෆීටර් පේපර් එකක් ගන්නවා ඒක තියෙනවා ෆනල් එකේ ෆිල්ටර් කරනවා. Just an easy physical method. අපි chemical reaction නිකම් මුකුත් වෙන්නේ නැහැ මෙතන. Just filtering. අපි ගෙදරදිත් කරනවානේ ෆිල්ටර් කරන්නේවා. When we are preparing a tea or when we are preparing a juice, we are filtering. So we can remove the seeds and all the things and all the lumps of milk in that way. So that's the separation of the component. ඉතින් ඔන්න ඔය විදිහට component separate කරන්න පුළුවන් mixture එක. So we learned here something new. At the beginning we get to know that a mixture contain few components, and now we have learned the second point. That means those components can be separated by using physical methods. ඒ කියන්නේ if they can be separated by physical method, they are not chemically combined. ඒවා chemically react කළා වෙනම compound එකක් හදලා තිබුණා නම් we cannot separate that by using a filtration like normal physical method. ඒ වගේ එකකින් අපිට separate කරන්න බෑ. Chemical reaction එකක් වෙලා තිබුණා නම් we have to perform a chemical reaction to separate those components on a chemical mixture. හැබැයි මෙතන එහෙම නැහැ. Just a mixture which can be separated by physical methods. Okay. And then තේරුණාද සිත්මි? අපි දැන් දෙකක් ඉගෙන ගත්තා. One thing is a mixture contains several components. What is the second point we have learned? Those components can be Hindi, Sipmi. Those components can be separated by using what methods?
By physical method.
Yeah, good. Physical methods. අපි ඉතින් ඔය physical methods කීපයක් ඉගෙන ගන්නවා මේ lesson එක අගදී. දැනට මම ඔයාලට එකක් කිව්වා filtration. ඊළඟ slide එකට යමු. There are some another mixtures. First one is well water. Water කිව්වම අපිට දැන් පේන්නේ නිකම්ම water විතරයි. But it's a mixture of several components. Mainly it contains water and some dissolved oxygen, dissolved carbon dioxide, and various salts. When we look at a well, we can see some fish. Because since fish are alive, they should have oxygen. That means oxygen is dissolved in water. And also we can see some plants. Plants, that means carbon dioxide is dissolved. Carbon dioxide is dissolved in water to absorb by plants. to carry out photosynthesis. ඉතින් එන්නේ විදිහට there are some components. ඊට පස්සේ various salts තියෙනවා. Normally, when we are boiling some water by using a kettle or a pan or something for a long time, we can see at the bottom of that container, there's a brown color after some time. Have you seen that kind of thing by using an electrical kettle or a kettle? Have you seen that? Have you seen that brown color at the bottom of a kettle? එන්න කෙටල් එක දැකලා නැද්ද? එහෙමද? What's the answer? Have you seen?
Yes.
Yes. The reason for that. Assume කරන්න පුළුවන් දෙයකට reason එක. What is the reason for that brownish? And සමහර වෙලාවට අපිට ඒක මේ සූරන්නත් පුළුවන්. කලක් යද්දි ඒක අපිට brush කරලා wash කරලා අයින් කරන්නත් පුළුවන්. Can you assume what is the reason for that brown color precipitation like thing at the bottom of a kettle? මොනවද ඒ deposit වෙනවා ඇත්තේ? Assume කරන්න මේක දිහා බලලා. Looking at the composition of this well water.
Various kind of salts dissolving water.
Yeah, good. That is the reason. කලක් යද්දී අපි හැමදාම water boil කරනකොට we are boiling for a long time. All the salts, different ions, different salts coming, they are settling up to the bottom of the container. That is the reason for that. So we can know that there are some different dissolves various salts. Sorry. And then we have another example, that is saline water or sea water. When it's come to saline water, we know that we get salt from sea. That means sea water or the saline water is a mixture which contains salt. That means sodium chloride. Not only sodium chloride, it has different components. At the end of this lesson, we are going to learn about the salt extraction too. So at that part, we are going to learn about what are the different salts in it, how they precipitate and everything. At the end, I'm going to just mention here that it's a mixture of mainly it contain water and dissolved oxygen and carbon dioxide as before, and then some salts like sodium chloride, calcium chloride, magnesium sulfate, and calcium sulfate. Mostly magnesium and calcium and sodium salts are there in sea water or saline water. And then I have given here how to separate that salt. That method is evaporation of water. Actually, what we do here in a salt ලුණු ලේවා එක කරන දේ තමා they take sea water, saline water into their fields. එයාලගේ අර තියෙන tanks වලට ගන්නවා. අරගෙන ඉවර වෙලා they are separating out the water by evaporation. අපි දන්නවා saltants තියෙන්නේ හම්බන්තොට වගේ ගොඩක් dry area වල. So these areas contain enough amount of sunlight and there's no continuous rains. නිතර වහින්නේ නැහැ. So they can be evaporate easily and they can be separated by evaporation. Actually, salt can be separated. Sodium chloride can be separated. There are many salts. Sodium chloride can be separated at the end by evaporation of water. ඉතින් අපි පස්සේ ඉගෙන ගන්නවා මේ අනිත් salts. ඒවත් එහෙනම් extract වෙනවා ඇතිනේ. There are methods to remove those. So here, now we have learned these things about the mixture. Now we can develop a definition for a mixture. So here it is given that Mixtures are matter consisting of two or more components. We have learned that. It has two or more components. ඒවා තියෙනවා කියලා අපි ඉගෙන ගත්තා. And which are not chemically combined. We also learned that. ඒවා chemically combined වෙලා නැහැ. And can be separated by physical methods. අපිට physical methods වලින් separate කරගන්න පුළුවන්. Evaporation, filtration, එහෙනම් පස්සේ අපි කරනවා heating, අපි sieving, sieve කළා. ඒ කියන්නේ අර ගරලා. ඔයගේ එක එක methods, physical methods වලින් separate කරන්න පුළුවන්. So this is the definition for a mixture. Is that clear to you? Clear to both of you?
Yes, teacher.
Yes, teacher.
Okay. Then we are going to learn further about these mixtures. දැන් mixture එකක් කියන්නේ මොකක්ද කියලා දන්නවා. දැන් අපි mixtures ගැන විතරක්ම කතා කරන්න යනවා. මේ වගේත් there are few differences. All the mixtures not same. අපි දැන් මම ඒවල examples කිව්වේ නැහැ. There are some different another examples of mixtures. As an example, මට කියන්න බැරි වුණා. Air is a good mixture. මොනවාද air එකේ තියෙන components? You know that from the previous grades. What are the compositions? Sorry, what are the components in a mixture? Mixture of air.
Oxygen, carbon dioxide,
Yeah.
nitrogen, and
Yeah.
other dust particles.
Yeah, different dust particles and sometimes different particles like pollens and all the thing, and sometimes different microorganisms, and all thing can be there, and also water vapor, and those can be observed in air. So air is a good mixture. අපිට ඕනි different gases තියෙනවා එකේ. That is another example. I think sometimes soil is a mixture. It contains sand, some gravel, some mud and dust, and also different microorganisms, and also some different minerals, iron, zinc, different minerals are there, copper, like different minerals are there. And sometimes so in that way it contains different components. So those are mixtures. I think here we are going to learn about those different kinds of mixtures. Mixtures are very different according to their composition. So we can divide those mixtures into few groups. Mainly we are going to divide those mixtures into two groups depending on their appearance and also their composition throughout the mixture. Mainly through the appearance and like the features like color and transparency and composition of the mixture. Composition කියන්නේ මම මුලදී මාලට කියලා දුන්නා. අපි දැන් fruit salad එකක් ගත්තොත් ඒ salad එකේ කොච්චර part එකක්ද කොච්චර amount එකක්ද තියෙන්නේ total amount එකකට fraction එකක් විදිහට අපිට ගන්න පුළුවන් කොච්චර amount එකක්ද දැන් අපි හිතමු mango. What is the amount of mango as a fraction to the total amount? අන්න ඒක තමයි අපි කියන්නේ composition එක කියලා. එතකොට here in different type of mixtures we have to consider about the composition. Composition අපි ලස්සනට පිළිවෙලට කරගන්න පස්සේ හැබැයි මෙතනදී අපි චුට්ටක් කතා කරනවා composition එක කොහොමද වෙනස් වෙන්නේ solvent different mixture to another mixture. So here we have some examples. Mixture of salt and water, mixture of sugar and water, mixture of copper sulfate and water, mixture of sand and water, mixture of mud and water. So we have 5 mixtures here. When we look at these mixtures, can you tell me what is the difference? What is the main difference? You can see here in the color or the composition of the mixture, of composition of a particular component in that mixture throughout the solution. අපි මුලින්ම ගමුකෝ කලර් එක ගැන. මොකද හිතෙන්නේ කලර් එක ගැන? මේකේ තුනක් තියෙනවා. Those three has some common feature and another two has some different another feature. When we think about the color, can you just tell me මොකක්ද අපිට මේකේ main difference එක පේන්නේ? මම තව ටිකක් ලේසි කරන්නකෝ. 1 2 3 comes to one group and fourth and fifth mixtures they are coming to another group. මොකද color එකේ difference එක වෙන්නේ මොකක්ද? color එක spread වෙලා තියෙන විදිහ. Can you tell me? කවුරු හරි කියන්නකෝ. විහිඳ කියන්නකෝ.
First tree in the first tree, color is evenly distributed throughout the mixture.
Yeah, that's good. And then Sydney, what is the comment about fourth and fifth mixture?
Their composition is different and color is not same even.
Yeah, that color is same. ඒ කියන්නේ first three, it has the unique, that means even distribution of the color. color එක evenly distribute වෙලා තියෙන්නේ. හැබැයි in the last two, it has two different colors. අපි fourth එක ගත්තොත් the bottom part it has the yellow color which is due to the sand settling down at the bottom, and upper part is somewhat clear water. So it has different color. And another one, fifth one, mud and water. අපි mud ටිකක් dissolve කළොත් නම් මඩ ටිකක් dissolve කළොත් ඒක bottom එක very very dark and upper parts are somewhat cloudy. ඒක clear වෙන්නේ නැහැ, somewhat cloudy and not transparent. අපි එතකොට in case of color it is that. And when we think about the transparency is even the first few mixtures are having some even transparency. අපි එක mix එකක් ගත්තොත් it has some constant transparency throughout the whole mixture. Salt solution එකේ it has a common transparency from top to bottom of the salt solution. Transparency is same, color is same, and especially the composition is same. Composition is the amount of matter in a unit volume. ඒ කියන්නේ අපි මේකේ unit volume එකක් අරගෙන බැලුවම අපි හිතමුකෝ මම ගන්නවා කියලා 1 decimeter, sorry 1 cubic centimeter, that means 1 milliliter. මම top area එකෙන්, ඒ කියන්නේ අර උඩ හරින් ගත්තත් milliliter එකක්, it has the same composition which I take from the bottom. We have to dissolve it evenly. We have to dissolve it well, and then we have to take. If we can measure the composition by using a particular method, we will get the same answer for both. That means color, transparency, composition are same. And also composition කියනකොට we have to think about the density too. Density එකක් ගත්ත හැකි. Mass of a unit volume. So it's also same. ඒ කියන්නේ same number of particles are in a unit volume. අපි දැන් මේක අරගෙන මෙහෙම ගමුකෝ. දැන් මේකේ මේ ඒරියා එකෙන් ගන්න වොලියුම් එකයි. මෙන්න මේ ඒරියා එකෙන් ගන්න වොලියුම් එකයි. If we take those out like this, if we can count the salt particle in these two smaller volumes, we will get same number of salt particles in each sample. Means two samples, they contain same number of salt particles. That is the thing. That is the meaning of the even composition. Similar composition or the similar density. Density is similar. That is the thing. And then same here for sugar solution and copper sulfate solution. They are equal. And when it comes to mud and water, those things are different. They are not equal. අපිට ඒක ප්‍රැක්ටිකල් එකක් තියෙනවා ටෙක්ස්ට් බුක් එකේ. ඒකේ තියෙන්නේ we have to take a mud solution like this. මෙතන මේ දීලා තියෙනවා වගේ we have to take a mud solution and then we have to take a metal plate. අපිට metal plate එකක් ගන්න කියලා තියෙනවා. That is one of activity in our book. We have to take a metal sheet and we have to prepare a solution of mud, dissolving some mud in water in a beaker. And then what we have to do is we have to take a drop from here and drop from the middle and drop from the bottom. On 3 places when අපි ඒක label කරමු A and B and C කියලා. If we label it like this, I'm taking those 3 drops like this. ඒ තුනම අරගෙන what we have to do is we have to heat this by using a candle or a spirit lamp or something. අපිට මේක heat කරන්න කියනවා. heat කරලා ඉවර වෙලා they ask us to observe the color or the transparency or the amount of clay particles in each drop. එතකොට අපි මේක vaporize කරලා ඉවර වුණාම ඒ කියන්නේ heat කළාම this water going to vaporize and we will get some residual matter. අර මම කිව්වා residues කියන්නේ ඉතුරු වෙන පුංචි solid particles වලට අපි කියනවා residues කියලා. Those residual matter on that metal plate, they are different from A to B and to C. When we think about this A has some small amount of mud particles. Then B, it is somewhat darker. So it has some more particles. And then C has more than that. C වල තියෙනවා ඔක්කොටම වඩා because it was taken from the bottom. ඒක ගත්තේ bottom එකේ. It is somewhat darker than the previous drops which have taken from the top and middle. ඔන්න ඔහොමයි මේ practical එකේදී කියන්නේ. So here we can understand the composition of the mixture or the color or the transparency of the mixture is not similar from place to place in some mixtures, but some are having similar transparency, similar color and similar composition. මෙතන මේ images දෙක නම් මාරු වෙලා තියෙන්නේ. මේක මෙතෙන් දෙන්න ඕනේ, මේක මෙතෙන් දෙන්න ඕනේ. Sugar water dissolve කළාම we will get a solution with a even transparency, even color and even composition. And when we dissolve sand and water, we will get somewhat different from that. Actually, which is given here is not a sand mixture, it's a mud mixture. But here, which is given here is a sand mixture. Now you have learned 2 types of mixture. We have 2 different names of these 2 mixtures. Those are here, it is same here. We call this as homogeneous. Homo, that means similar. And homogeneous mixture, here it's a heterogeneous mixture. Hetero means difference. Hetero. Those 2 words are used to define these 2 types of mixtures. So that is given here. Homogeneous mixtures versus heterogeneous mixtures. Here you can observe that there are few differences. Homogeneous mixtures have a uniform composition throughout the mixture. Heterogeneous mixtures have a mixed composition which may vary from point to point. ඔගොල්ලෝ එක දැක්කා. අර mud particles ටික it is different from place to components are not visible to the naked eye in a homogeneous mixture. අපිට පේන්නේ නැහැ. ඔක්කොම දැන් sugar dissolve කරාම නැත්නම් salt completely dissolve කරාම අපිට පේන්නේ නැහැනේ මොනවද තියෙන්නේ කියලා. But in a sand mixture or a mud mixture, we can see the components separately. අපිට separately පේනවා. And here, for a homogeneous mixture, component cannot be separated easily. Easily separate කරන්න බෑ. The reason is when we are dissolving some salt or when we are dissolving some sugar to make a uniform homogeneous mixture, we can't separate those things easily. එක dissolve කරාට පස්සේ අපිට separate කරන්න අමාරුයි. But we can use this you use some heat to evaporate the water, and we can collect salt or sugar at the bottom of the container, but it is not easy. But when it's come to a heterogeneous mixture, components can be separated easily. ඒක easily separate කරන්න පුළුවන්. As in the example for mud mixture, you saw that the components can be separated easily. අපි මේ metal plate එක උඩ few drops were placed here and we heated that. අපි heat කළාම water is evaporated, mud particles are remaining on the metal plate. We can separate the components easily. අනේ ඒක තමයි. Those are few differences between homogeneous and heterogeneous mixtures. ඊට පස්සේ අපි යනවා to look at another difference. Here, a few examples are also given. In a homogeneous mixture, the physical properties such as color, transparency, and density are identical everywhere. And in a heterogeneous mixture, the physical properties of the mixture such as color, transparency, density are different from place to place. ඔන්න එහෙනම් differences ටික. These features are similar here in homogeneous mixture. They are different from place to place in a heterogeneous mixture. ඉතින් those are the differences between homogeneous and heterogeneous mixture. Is that clear to you? Vihindi, Sidmi? Clear
Yes.
the ටික? Okay. ප්‍රශ්නයක් තියෙනවා නම් පුතේ අහන්න මැදදී හොඳේ. If you have any question, you can ask. ඊට පස්සේ so here homogeneous mixtures have another name. යට වෙන නමක් තියෙනවා. We call them as solutions. අපි හැමතිස්සෙම කියනවානේ sugar solution, salt solution in that way, and hydrochloric acid solution. Mostly we are using solutions in laboratories. අපි school laboratory එකේ අපි use කරන්නේ solutions. මඩ වගේ අර නිකම් කිසිම පිළිවෙලක් නැති mixtures use කරන්නේ නැහැනේ. pure mixtures. non pure ඒවා අපි හැම use කරන්නේ නැහැ. ඒ කියන්නේ mixtures separate කරන්න බැරි ඒ වගේ ඒවා use කරන්නේ අපි day to day life එකේදී සමහරවිට ඒ වගේ දේවල් ගොඩක් හම්බෙනවා. But in a laboratory what we mostly get is solutions. That means homogeneous mixtures. මොනවා හරි dissolve කරන්නේ acids, bases, and all the chemicals are dissolved to make solutions. So we have few questions. 2 questions. Shall we try those 2? These are few O-level past paper questions. That this lesson is too long, but it is not difficult. මේක දිගයි හැබැයි අමාරු නෑ මේ lesson එක. සිත්මේ විහින්දි අපි try කරමුද මේ examples දෙක questions දෙක?
Okay, teacher.
පළවෙනි එක. Which of the following is a homogeneous mixture? Wheat flour plus water. Second one, ethyl alcohol plus water. Third one, coconut oil plus water. Fourth one, clay plus water. මොකක්ද මේකේ homogeneous mixture එක?
Second one.
Which means second
ethyl alcohol plus water.
Yeah, ethyl alcohol plus water. Oh, එක තමයි answer එක. Because we also know that we are using hand sanitizers these days. It contains alcohol. So it is not a heterogeneous mixture. We have a clear solution of alcohol as a hand sanitizer. So ethyl alcohol plus water is a homogeneous mixture. ඊට පස්සේ අපි යමු second question එකට. Which of the following substances can be mixed with water to make a heterogeneous mixture?
Wheat
එකම
flour.
question. Yeah, wheat flour. That is the thing. බලන්නකෝ එකම question එක එකම answers ටික. හැබැයි අහලා තියෙන්නේ past papers දෙකක. එකම ටික චුට්ටක්වත් වෙනස් වෙලා නැහැ. වෙනස් වෙලා තියෙන්නේ copper sulfate, sugar and coconut oil විතරයි. අනිත් ටික ඔක්කොම equal. So here, if we take wheat flour, we will have a heterogeneous mixture. ඉතින් up to now, we have divided the mixtures into two groups. What are those two groups? Can you tell me again? What are the two groups of mixtures we have learned until now?
Heterogeneous mixtures and homogeneous mixtures.
Good. Heterogeneous mixtures and homogeneous mixtures. And also, here now we are going to classify those heterogeneous and homogeneous mixtures further depending on their physical status. That means we have three states of physical nature. What are the three physical states of matter?
Solid, liquid, and gas.
Yeah, solid, liquid, and gas. Depending on that thing, we are going to divide those mixtures into few groups again. එතකොට කරන්නේ solid, liquid, and maybe liquid or solid, and also gas liquid. In that way, we are going to divide those things further. So here I have taken the table which was in the textbook. That is given here two components. That means first component and second component, and nature of the mixture. It is given as whether it is homogeneous or heterogeneous, and then it has termed එක වෙනම term එකක් දීලා තියෙනවා whether those two components are solid, gas or liquid. So this first example, wheat flour and water. When we take wheat flour, it is solid දෙයක්. Then we dissolve it in a liquid which is named as water. එතකොට solid liquid has come together and it is heterogeneous. අපි දන්නවා ඒක heterogeneous. දෙය කළාම it is not dissolving properly. Something at the bottom as a lump of wheat flour. So it's a solid, liquid, heterogeneous mixture. And then salt and water. When we dissolve some salt in water, it is true that salt is solid and water is liquid, but they are homogeneous. Solid, liquid, homogeneous mixtures. ඔන්න එතන තියෙන difference එක. Both are containing solid and liquids, but one thing is a heterogeneous mixture, other one is a homogeneous mixture. Then next example, coconut oil plus water. Coconut oil, water, both are liquids, but they are not miscible. ඒවා dissolve වෙන්නේ නැහැ එකට. So they are not mixing properly. We can see two layers separately. That means the composition, color, transparency, both are not, all are not equal. They are not even from one point to another of the mixture. So those are heterogeneous. So here it's a liquid heterogeneous mixture. An ethyl alcohol water It's mixed clearly and it's homogeneous. Liquid homogeneous mixture. And sugar plus salts, sugar ටිකක් අරගෙන ඒ කියන්නේ when sugar and salt mixed together, whether they both of them are in powdered form, both are although they both of them are solid, ඒ දෙකම solid උනත් ඒ දෙකම powder form එකකින් ඉන්දියා දෙකම හොඳට miscible උනත්, but they are heterogeneous. The reason is the properties are not same from place to place. If we taste one place, it will give us a salty taste. Another place give us a uh, sweet taste of sugar. And also the texture of sugar particle and sugar crystal and salt crystals are not same. The texture එකේ වෙනසක් අපිට පේනවා. In that way, it's a solid mixture, but it's heterogeneous. දැන් අපිට එකපාරට හිතනවා sugar salt එකට දැක්කමහම එහෙනම් එක වගේනේ මික්ස් වෙලානේ පේන්නේ නැහැනේ වෙනසක් නැහැනේ ඒක නිසා මේක නිකන් even composition කියලාත් හිතෙනවනේ කියලා. එනකොට this composition is not same. It is different. So it is heterogeneous. ඊට පස්සේ තව අපිට තියෙන අපි දන්නේ නැති examples අපිට පුරුදු නැති examples ටිකකුත්. Copper zinc එකට එකතු කරනහම copper කියන ඒ කියන්නේ අපි කියන තඹ copper coils තියෙනවනේ. අර wire ඇතුලේ තියෙන ඒවා. ඊට පස්සේ zinc කියන metal එක when those are both solids. Then நம்ம solids උනාට when they come together, when they are melted, when they are molten, and when they are mixed together, it will make another a new mixture of metals. A mixture of metals are named as alloys. අපි alloys කියලා කියනවා. කියන්නේ ලෝහ දෙකක එකතුවක්. metals දෙකක එකතුවකට අපි කියනවා alloy එකක් කියලා. A double L O Y. alloy කියලා කියනවා mixture of metals. A mixture of metals. Here it makes a mixture of metal. That means it's homogeneous. Composition is same from place to place. We call this special metal which is from alloy which is formed at the end of the mixturing of copper and zinc together as brass. මේ alloy එකට අපි normally කියන්නේ brass කියලා. පිත්තල කියලා අපි අහලා තියෙන්නේ. ඉතින් මේ පිත්තල හදන්නේ copper and zinc කියන metal දෙක එකට එකතු කරලා. ඉතින් it's a solid homogeneous mixture. අපි දැන් පිත්තල අර මොනවද තියෙන්නේ අර එක එක දැන් තියෙනවානේ අර ලොකු පහන් උස පහන් තියෙනවා. එක පිත්තල එක එක බඩු තියෙනවා වගේ වල. ඉතින් ඔය එකක්වත් ගත්තට අපිට separate කරන්න පුළුවන් ද අර copper zinc separate කරන්න බෑනේ. නේද? Isn't it? It cannot be separated. හරියට අර sugar solution එකක්, salt solution එකක්, it cannot be separated. So it's a homogeneous mixture. But both are solids here. ඊට පස්සේ අපිට තියෙනවා another two examples, carbon dioxide gas plus water. මෙතනදී one is hot water, another one is cold water. Carbon dioxide is a gas. You will learn in this lesson later in this lesson that gases dissolve in cold water. සීතල වතුරේ තමයි gases dissolve වෙන්නේ ගොඩක්. They are not dissolving. They are less dissolving in hot water. ඒ කියන්නේ soda. That means it's a drink which has prepared by mixing water with carbon dioxide gas. අපි කියනවා carbonated drinks කියලා කියනවා ඒවට. Carbonated drinks. ඉතින් carbonated කියන්නේ carbon dioxide added කියන එක. ඉතින් carbon dioxide is a gas, water is a liquid, both are added together at very cold conditions at high pressure. Itin cold water can easily dissolve, it easily mix with carbon dioxide or whatever the gas it can easily mix with. The here given example is carbon dioxide gas. Itin wanna, it's a gas liquid homogeneous mixture. But in hot water, gases are bubbling. අපි දන්නා අපි වතුර ටිකක් boil කරනකොට. You will see that when you turn on the kettle, you can see on the sides, on the walls of the kettle, you can, if you can see through the wall of the kettle, the gas bubbles are moving up. That means maybe oxygen, maybe carbon dioxide. Those gas bubbles are separating from the solution. That means they don't like to mix with. It's a heterogeneous mixture. අපිට easily පේනවා. We can see clearly that the composition of the mixture is not same. තැන තැන bubbles තියෙනවා. That is it. Then these are the, make clear the Vihinti, Sydney.
Yes, teacher.
මේක මතක තියාගන්න තියෙන්නේ ඔයාලට physical state එකත් එක්ක වෙන change වෙන එක එක groups. එතකොට ඔයාලට ඕනෙම mix එකක් දුන්නාම you can see whether the given two components are solids, if not liquids or gas, then you can name the mixture. And then we are moving to new part. අපි යනවා ඔය solutions ගැන කතා කරන්න. Further, මෙතන වෙනකන් අපි කතා කළේ it's like a classification of mixtures. Mixtures අපි classify කළා එක එක විදිහට. Homogeneous, heterogeneous, and then depending on the physical state, we give different terms to those mixtures. ඉතින් ඔය ඔක්කොම mixtures නෙමෙයි අද අපි කතා කරන්නේ solutions ගැන විතරයි මේ lesson එකේ මැද හරියේදී. ඉතින් now we are moving to that part. Those are the solutions. Then here, in a solution, there are two parts. Solution එකක් ගත්තාම it has main two parts. One part is the solute, other part is the solvent. Solute, solvent. We have to differentiate what is the solute and what is the solvent in a substance which is in a large amount. කියන්නේ ගොඩක් තියෙන එක. A component which is in excess, is named as the solvent. ගොඩක් තියෙන, ඒ කියන්නේ component එක, composition එක ගත්තාම ගොඩක් තියෙන්නේ solvent එක. The component which is present in excess is the solvent. That is solvent. And solute is the component which is that means that there may be different few solutes in a particular mixture. මොනවා හරි rest of the components. අපි හිතමුකෝ දැන් in here in this first example there is some little amount of salt and a bottle of water. Here we have water as the solvent and salt as the solute. ඉතින් මේකටම අපි මොනවා හරි sugar දැම්මොත් it has two components now. It not only two components with water, both components may be three if we add sugar too. ඉතින් ඔය තුනෙන්ම large amount එකක් අපිට තියෙන්නේ water. So we name it as the solvent. And the rest of the component which is in less amount are named as solutes. So finally here what we get is salt water. Here solvent is water, solute is salt. And here in the second example we have another solution. These blue color crystals, when you see that you have to identify this is the copper sulfate. This copper sulfate, some little amount of copper sulfate is going to be dissolved in water. Water is the solvent here, solute is the that little amount of copper sulfate, and both are mixed together, we will get the copper sulfate solution. Here, solvent and solute. And here we have to learn, we have to remember what is the solvent, what is the term which is used to express the thing which is in excess, in a solution, and which is in less amount in a solution. So solvent is the component. එක මතක තියෙන්න ඕනි. component which is present in excess. Present in excess. මේක මතක තියෙන්න ඕනේ. present in excess. ගොඩක් තියෙන component එක තමයි solvent එක. එතකොට මේකේ අපි මේකේ dissolve කරලා තිබුණා නම් දැන් අපි හිතමුකෝ මේතන copper sulfate ගොඩාක් අරගෙන දැන් එතන එක example එක ගලපෙන්න. කමන්න මෙතන මික්ස් කරලා අපිට හිතන්නත් පුළුවන්. solute එක විදිහට දැන් මෙතනදී අපි ගත්තේ we take as the copper sulfate. So if we take large amount of copper sulfate and we are adding little amount of water, and if we can calculate by using a particular method, what is the amount of water and what is the amount of copper sulfate, if we get a higher number, කියන්නේ ලොකු number එකක් අපිට ලොකු answer එකක් එනවා නම් as the composition of the copper sulfate, water වලට වඩා ලොකු number එකක් එනවා නම්, here in that case our solvent is not the water. ඉතින් අපි එහෙම normally prepare කරන්නේ නැහැ. මොකද අපිට ඕනේ clear solution එකක් හදාගන්නේ. What we need is a copper sulfate solution in a laboratory. So we are not making a slurry like thing by using copper sulfate. ඉතින් එහෙම වුණා නම් ඒක solution එකක් විදිහට ආවත් අපි හිතමුකෝ slurry එකක් වගේ නිකන් thick එකක් ආවා කියලා. එහෙමනම් it's not a solution with water as a solvent. Actually it's like water is dissolved in copper sulfate. Water dissolve කළා වගේ copper sulfate වල. එතකොට දැන් අපි normally කරන්නේ what we do is salt is dissolved in water. That means we adding some salts to larger amount of water. So water is the solvent in this case. That is how we can differentiate solute and solvent. And then in this way, when we are dissolving any solute in any solvent, there are few factors affecting on the ability. That means ability to be soluble, affecting on the solubility of a particular solute in that particular solvent. A solvent එකේ අර solute එක soluble වෙන එකට there are few factors affecting on that. Mainly there are 3 factors. So before learning about those things, before learning about the factors affecting on the solubility, we have learned what is this solubility is. Solubility කියන්නේ අතන මේ නිකම් water ටිකක් අරගෙන salt දිය වෙනකොට දිය වෙලා යන එක නෙමෙයි. It has a definition. It has a particular correct amount. එහෙම තියෙනවා. So here it has a definition like this. The solubility of a solute at a given temperature is on a special term එක. මේක අපි define කරන්නේ for a specific temperature, given temperature. Temperature එකක තමා මොකද අපි temperature එක වෙනස් වෙනකොට it changes the solubility. We are learning it later, but I have to tell it here of those factors. So definition here is for the solubility is the mass of that solute which dissolve in 100 grams of the solvent at a certain temperature. Always we are expressing the solubility as the mass of the solute. If it is salt, the mass of the salt which dissolve in 100 grams of water at a particular temperature like 25 degrees of Celsius. In that way, we can take the solubility of salt, especially on that temperature. Then 25 degrees වලනේ අපිට ඒක change කරන්න පුළුවන්. 30 degrees ගත්තොත්. We can use a thermometer to control the temperature. Then we can tell it as the mass of the salt which dissolve in 100 grams of water at 30 degrees Celsius is named as the solubility of salt at 30 degree of Celsius. ඒ කියන්නේ salt ගත්තොත් 30 degree Celsius වලදී තිහේදී salt වල solubility එක තමා the amount of salt, the mass of salt dissolved in 100 grams of water at that temperature. ඒ temperature එකේදී කොච්චරක් salts දිය වෙනවද? Water 100 milliliters වල. So here I just told it as 100 milliliters because 1 gram is equal to 1 cubic centimeters. 1 cubic centimeter is equal to 1 milliliter for water. Water වලට මේක this is a constant for water. ඉතින් water අපි 1 gram කිව්වත් එකයි 1 milliliter කිව්වත් එකයි 1 cubic centimeter කිව්වත් we are defining a particular same amount. ඉතින් what we have to do here, we have to take 100 grams of water, 100 milliliters of water. Then if it is water only, මේක water නම් විතරයි අපිට ගන්න පුළුවන් 100 milliliters. But if it is another solvent, we have to take this mass specially. මේක measure කරලා අරගෙන තමා අපිට අපේ solute එක dissolve කරලා බලන්න වෙන්නේ to find out the solubility of that solute in that particular solvent in the given temperature. මේක තේරුණාද? ඔය දෙන්නට තේරුණාද solubility කියන්නේ මොකක්ද කියන එක?
Yes, teacher.
Yes. එතකොට අපි මොකක්ද ගන්න mass එක solvent එකෙන් කොච්චර mass එකක් ගන්න ඕනේද? මේක හොයන්න නම්. කොච්චර amount එකක්ද ගන්න ඕනේ? solvent එක කොච්චරක් කරන්ද අපි dissolve කරලා බලන්න ඕනේ? What is the amount of solvent we have to take to check whether what is the amount of solute which is going to be dissolved here? What is the amount of solute we have to take here? Always we have to take 100 grams of the solvent. And we have to maintain a particular temperature. Especially here. We have to maintain a special temperature, particular constant temperature, and we have to use 100 grams of solvent. ඒ දෙක specially continue, ඒ දෙක constant වෙන්න ඕනේ. අපි හිතමුකෝ දැන් we want to dissolve some particular type of organic අපි හිතමු අර මොනවද jack glue තියෙන්නේ අර කොහොල්ල වගේ දෙයක්. jack glue වගේ දෙයක් අපිට dissolve කරන්න ඕනේ kerosene oil වල, ඒ කියන්නේ භූමි තෙල් වල. So we have to take 100 grams of kerosene oil. ඊට පස්සේ temperature එක it will be any temperature අපිට use කරන්න ඕන. අපිට any temperature නම් අපි ගමු 30 degrees Celsius. So we have to continue that. We have to maintain that temperature while we are dissolving. අපිට we have to use a thermometer and we have to maintain that temperature. And then we have to dissolve our glue sample. We have to dissolve, dissolve, dissolve. What we have to do here is අපි චුට්ටක් දානවා මුලින්ම and dissolve it completely. And we are adding another few and dissolving completely. And then again we are adding another little amount. In that way, we are adding little by little to the solvent until it comes to a point where that solute is not further dissolved. තව චුට්ටක් ඉතුරු වෙනවනේ අපි ඔය දාගෙන යනකොට අපි හිතමුකෝ දැන් ඒක ටිකක් අමාරු එක්සැම්පල් එකක් නේ අපි ගමු we are going to dissolve sugar in water to find out the solubility of sugar in water at room temperature කියන්නේ 25 degrees වලදී solubility එක බලන්න අපි දැන් හදනවා. Here what we have to do is we have to measure 100 grams of water. අන්න ඒක හරි. And we have to take a thermometer and put it into the water beaker. ඒක දාන්න ඕනේ. මොකද we want to maintain that temperature. Then we have to add little amount of sugar. While we are adding, we have to count the amount. අපි හිතමුකෝ දැන් මේ 10 grams and another 10 grams. If not, gram by gram, we are adding little by little. In that way, we will come to a point, if we add more sugar, it's not going to be dissolved. It is settling down at the bottom. ඒක ඉතුරු වෙනවා bottom එකේ. ඒ කියන්නේ dissolve වෙන්නේ නැහැ. At that point, අර ඒ පස්සේ දාපු amount එක නැතුව අර මුලින් දාපු amount එක තමයි. එහෙනම් it's the solubility of sugar in water at that temperature. ඒක තේරුණාද? විහින්දි? සිද්දි?
Yes, teacher.
ඔව් ඒක දැන් ඔයාලට වුණත් ඒක ඒ කියන්නේ අපිට තර්මෝමීටර් එකක් තියෙනවා නම් ඕක කරලා බලන්න අපිට පුළුවන්. චුට්ට චුට්ට ඇඩ් කර කර තව දුරටත් ඒ කියන්නේ further dissolve වෙන්නේ නැති point එකක් එනවනේ. අන්න ඒ point එකේ තමයි තියෙන්නේ solubility of that solute. ඒ amount එක විතරමයි එයාගේ dissolve වෙන්නේ ඒ temperature එකේදී. When the solvent volume increase, it's going to be dissolved, but we are taking particular constant. When the temperature is increasing, අපි ඔක පොඩ්ඩක් රත් කළොත් it is again dissolving. That's why we are using hot water to make a tea. අපිට sugar ඔය ඔක්කොම dissolve කරගන්න ඕනේ හන්දනේ අපි hot water ගන්නෙ. නැතිනම් tea හදන්නත් cold water එකක් ගන්න තිබුණානේ. So here we are maintaining that temperature and taking 100 grams of solvent and dissolving our solute to find out the correct amount. That is how the solubility can be taken. අපිට කරන්න පුළුවන් දෙයක්. We can do that. ඉතින් ඔන්න දැන් මෙතන කරලා තියෙනවා. There's a particular solute which is given here in this green color, and it is added to this solvent and solution is formed. At the end, they have found that only 27 grams of the solute can be dissolved in this solvent without making a precipitate at the bottom. Precipitate එකක් කියන්නේ මොනවා හරි residues යට ඉතුරු වෙනවා නම් අපි කියන එකට precipitate එකක් කියලා. Settle down වෙන දෙයකට solution එක අපි කියන precipitate එක solid දෙයකට. So until that point, it is only 27 grams. එහෙම ඉතුරු වෙන්නේ නැතුව dissolve වෙන්නේ 27 gram විතරයි. So that is the solubility of this solute at 25 degrees of Celsius. That is it. Then අපිට මේක දැන් water විතරක් නෙමෙයි ඕන දෙයකට කරන්න පුළුවන්. We can use an acid like අපි හිතමුකෝ මෙහෙම like anything. We can take a calcium hydroxide sample from a laboratory And also from the laboratory, we can take some sodium hydroxide powder. And then some any compound we can take like this. We can find the solubility like this. We can take any. And then we are coming to the next slide. Now factors affecting the solubility. දැන් චුට්ටක් විතර මේකෙන් අපි දන්නවත් එක. මොකද මම ඔයාලට කිව්වා when we heat something we can dissolve it well. Sometimes when we cold something we can dissolve that way. Cold කරාම වැඩිපුර dissolve වෙන්නේ මොනවද? Solids the gases the liquids the
Gases.
yeah, gases. When we cold a mixture of gases and solvent, it's going to be dissolved very well. So temperature is affecting on the solubility. Here this is a sample which contains some glucose and water. In cold water, it is not going to be dissolved well. But in hot water, only little amount of residue is at the bottom, but most of them is dissolved. You can see here, the transparency of the solution has decreased in the second diagram. Transparency has decreased. ඉස්සෙල්ලා එකේ එහෙම නැහැ. Cold water වල මොකද? It is not dissolving well. In hot water, it is dissolving well. And then next example, nature of the solute. The second factor which is affecting the solubility is nature of the solute. So here, nature of the solute means some solutes are having some different chemical natures. That means some are polar, some are non-polar, some are organic, some are inorganic. Polar, that means it has some ability to attract positive and negative ions. Polar කියන්නේ ඒකයි. It has two ends with positive charge and negative charge. So negative charge particle can attract, and negative charge part of that particular thing can attract the positive things. එතකොට, if we think about a water molecule, it's like this. අපි දැන් water molecule එක ගත්තාම මේ ඇඳලා තියෙන පුංචි water molecule මේක අපි මෙහෙම ඇන්දොත් it has an oxygen atom and two hydrogen atoms. So this H is slightly positively charged. පොඩි positive charge එකක් තියෙනවා යාට delta H කියනවා. මේ ලියලා තියෙන it's not 8, it is delta H. Delta කියන්නේ is a little amount of positive charge, and this oxygen is having a negative charge. ඉතින් මෙයාට negative, මෙයාට positive තියෙනවා. So when we put something into this water sample, if it is a polar substance like this, මෙතන පේනවා දැන් මේ පුංචි this yellow color circles are having negative charge and positive charge. බලන්නකො positive charge එක්කෙනාට කිට්ටු වෙන්නේ කවුද? This negative charge oxygen atom side of the oxygen atom side of that water molecule attracts toward the positive end of the molecule. A component එකේ ඒ අපි add කරපු solute එකේ positive end එකට එනවා අපේ water molecule එක. Water molecule එකේ negative charge side එක. අනේ විදියට. And here to the negative part, hydrogen molecules will attract. Hydrogen atoms will attract to the negative sides. So in that way, not only the nature of the solute, nature of the solvent also affecting on the solubility. එතකොට මෙතන solute is this, solvent is water. So their polarity, that means whether they are polar or non-polar. Non-polar කියනවා if it is like kerosene oil, like organic solutes, organic solutions, they are not polar. Mostly they are not polar. They are polar නෙමෙයි. And even coconut oil is not polar. It's a organic molecule. It's not polar. Yeah, polar කෙනෙක් නෙමෙයි. ඉතින් that's why coconut oil is not miscible in water. That's why those are not mixing together. Their polarity is different. One thing is polar, other one is non-polar. And also one component is organic, other one component is inorganic. So organic කියන එක අපි ඉගෙනගෙන තියෙනවා grade 10 වලදී. Molecule which contain C, H and O. That means mainly C, H. අපි කියනවා molecule which contain carbon are organic molecules. The molecules which doesn't contain carbon are inorganic කියලා. ඉතින් එහෙම කියලා දැන් there are some molecules which contain carbon but those are inorganic like CO2. It contain carbon but it's an inorganic molecule. එතකොට අපි normally ටිකක් උඩට යනකොට ඉගෙන ගන්න නම් CH දෙකම තියෙන ඒවා තමයි organic කියලා. ඉතින් අපේ පොත්වල දීලා තියෙන්නේ molecule which contain carbon is a organic molecule කියලා. So we have to remember that. And then inorganic. We know that molecules doesn't contain carbon, water, some mineral ions, calcium and chloride ions. So calcium chloride, sodium chloride, all are inorganic and polar. So they can easily dissolve in polar inorganic solvents like water. In that way, the nature of the solvent and nature of the solute is affecting on the solubility. Here there are some another examples again. Water is polar, it is given here. And another molecule. Molecule එකේ නම නැහැ. There are some molecule. It has delta H, delta minus, sorry, delta plus, delta minus charges. You can put plus minus charges තියෙනවා. ඉතින් plus charges attract towards the oxygen atom in a water molecule. Minus charges attracts with the plus charges in hydrogen atoms in a water molecule. In that way, they are going to be dissolved. මෙතන ආයෙ දීලා තියෙනවා dissolving salt. It's an ionic solute in water. We have a special term here. We have to remove this one. Like, dissolve, like. මේක තමයි අපේ word එක. අපිට මේක මතක තියාගන්න. Like, dissolves, like. Easily, within by using 3 words, we can tell that like, dissolve, like. That means the nature of when we consider about the nature of the solute and nature of the solvent, similar, the components with similar features dissolve together. Polar goes with polar, non-polar goes with non-polar. And organic solvents goes with organic solutes. Inorganic solutes come with the inorganic solvents in that way. So here there's another few examples: salt water and salt oil. We can see here they are not miscible and both are separated here. Layers are separated. And it is given here again, like, dissolve, like. Polar solute dissolve in polar solvents. Non-polar solute tend to dissolve in non-polar solvents. Same thing which we have discussed yet. Now we have another classification again. Now we are going to classify all the solutes and all the solvents into few groups depending on their nature. That means whether they are polar, non-polar, or whether they are organic or inorganic. In that way, we have 4 groups. Then first they are dividing into two groups, organic and inorganic, and then we are dividing inorganic group into another two groups named as polar and non-polar. එතකොට alcohol, it's a polar organic solvent. Polar and organic. Alcohol, it's contain it the chemical formula of alcohol is CH2 or H, CH2OH. So, sorry, CH3OH, CH3OH. So, it's alcohol. It contains carbon and hydrogen. So, it's an inorganic. Sorry, it's an organic solvent, and it is polar. This OH is having a minus charge. So it is polar. Polar organic solvent. So formalin, acetone, both are like that. Both of them are like, just like alcohol, they are polar. And non-polar. මේ examples ටික ඉතින් චුට්ටක් මතක තියාගන්න වෙනවා. මොකද අපි experience කරන්නේ නෑනේ ගොඩක් ඒවා ගැන. ඊට පස්සේ for non-polar component, there are some organic solvents, they are non-polar. Hexane, benzene, and carbon tetrachloride. Carbon tetrachloride කියන්නේ CCl4. Tetra means 4. අපි ඒවා ඉගෙනගෙන තියෙනවා chemical formula කරද්දී. Tetra කියන්නේ 4. There are 4 chlorine atoms. Tetrachloride. Carbon tetrachloride. අපි molecule එක ඇන්දොත් it's like this. We are familiar with these things. මතකයි නේද මේවා? අපි grade 10 වලදී කතා කරනවා. Carbon tetrachloride. It doesn't have a polar end. Those are just covalent bonds. These covalent bonds are not having polarity here. There are some covalent bonds with polarity. අපි ඒකනේ water molecule එක ගත්තේ. Water molecule is it is contained in two covalent bonds. Covalent bonds එකක් තමයි තියෙන්නේ. But due to this electronegativity difference between this H and O, this O has a high electronegativity, and hydrogen doesn't have that much electronegativity to attract electrons toward it. The electronegativity වැඩි කෙනා මොකද කරන්නේ? අර බොන්ඩ් එකේ තියෙන electrons ටික එයා පැදලා attracts කරනවා. So it has more negativity. And electrons ගොඩක් තියෙන කෙනා, electrons are negatively charged, it has more negativity. So that's why it has become polar. අපි මේවට කියනවා special name එකක්, polar covalent bonds. Polar covalent bonds කියලා කියනවා. Then it is just about chemical bonds, about these things. මම ඒක කියලා දුන්නේ. මොකද we have to define those things. When we know these things in detail, we don't have to memorize by heart. It's like අපිට කටපාඩම් කරන්න ඕනේ නැහැ. We can just remember by the things we know. ඒවට relate කරලා අපිට මතක තියාගන්න පුළුවන්. Here water, it is given here. It's a polar component, water, and it's inorganic, no carbon. And ammonia, NH3, ammonia කියන්නේත් in the same way it is having some polarity, because nitrogen is also at the same side of the periodic table, which is oxygen is in. Oxygen තියෙන පැත්තෙම එයත් non-metal එකක්. So non-metals are having some high electronegativity. So it has some delta minus charge. And also HCl, that is again a covalent bond which has made by sharing two electrons of H and chlorine. Chlorine contributes one electron and H contributes one electron, and they are making a covalent bond by sharing these electrons. But chlorine has a high electronegativity, so it attracts electrons in the bonds and become negatively charged. So in that way, sorry, hydrogen chloride is a polar inorganic substance. And then some non-polar inorganic substances are there. Carbon disulfide, that means CS2. Carbon disulfide, di means 2, CS2. Liquid carbon dioxide, CO2 liquid. අපි දන්නවා fire extinguishers වල තියෙන අර red color අර අපි දකින ඕනේ තැනක ඕනේ building එකක අර පැත්තකින් තියෙන fire extinguishers වල තියෙන්නේ it contain liquid carbon dioxide. Liquid carbon dioxide is a non-polar inorganic substance. Liquid carbon dioxide. So in that way, ඉතින් දැන් මේ බෙදලා තියෙන විදිහටම අපිට define කරන්න පුළුවන් polar organic solutes or solvents. Now, there are some mixtures like that. Polar organic solutes, polar organic solvents, they come together. Polar organic come together. Again, like that, like this or like. Non-polar organic solutes or solvent, they come together. Polar inorganic and non-polar inorganic. In that way, these types of solutes and solvents come together. If we take any of this couple like that, they are dissolving each other. අපි එකක් ගමුකෝ. Alcohol and water. Polar organic solute and polar inorganic solvent. They come together and dissolve. ඊට පස්සේ another example, carbon disulfide, CS2. We can take CS2 and we can dissolve hexane in it or benzene and then CCl4 in it. They mix together well. Non-polar mix together and polar organic solvents or polar organic solutions mix together in that way. අපිට මේ ඕනෙම couple එකක් mix කරන්න පුළුවන්. एक क्लियर दो දෙන්නට විහින්දි සිඩ්නි ක්ලියර්ද පුතේ ටික
Yes, teacher.
ඔදෙන්ට කම්මැලිද අද ලියන්න මොකුත් නැහැ වගේනේ අනිත් දවසේ මේ ඔයාලා උදේ මම ගොඩක් වෙලාවට when we are having the class then today we started the class at 6 p.m. Normally we are having the class from 5 to 7. So you have to come on the next day at 5 p.m. So when you come to the class, mostly on the previous day of the class or the if not in the morning of the day of the class, I am uploading the tutorial. If you are having a new tutorial, I am uploading it. So you can take a print out and you can have a hard copy with you. Then you can write those things with me. අපි එහෙම කරනකොට ඔයාලට අහන් ඉන්න තියෙන ගතිය අඩු වෙනවා. දැන් අද නම් ඉතින් චුට්ටක් අමාරුයි. ඒ නිසා ඒක අපි එහෙම කරමු නේද? පේපර් එක අනිත් දවසේ hard copy එකක් අරගන්න. Okay then. You have to take a hard copy or then you have not with you. එතකොට ඔයාලට ලියන්න පුළුවන් ඒකෙන්. Then I'm coming to the next part. අපි අද මෙතනින් මේ චුට්ට discuss කරලා composition වලට මම එන්නේ නැහැ අද. We are going to discuss in the second class. In the second class, I'm going to stop here today with factors affecting the solubility of a gas. මේ චුට්ට විතරයි මෙතනදී අපි discuss කරන්නේ අද. You already know that gases are dissolving in cold water. Now you know that one factor, that is temperature. That means temperature is affecting on the solubility of a gas in particular solvent. mostly when we are preparing carbonated drinks like Pepsi, Coca-Cola, and any of those, when we open a bottle of a carbonated drink, we will see some air bubbles are releasing. That's due to we call them as fizzy drinks because it's due to the releasing of carbon dioxide gas which is dissolved in it. So that is one experience we have taken in our day-to-day activities. Another experience is when we take a unopened, that means closed soda water bottle from a shop, අපිට කඩෙන් ගන්න වෙනවා අලුත් soda bottle එකක්, and same type of empty bottle which is filled with water. අපිට ඊට පස්සේ ගන්න වෙනවා ඒ product එකේම තව bottle එකක්, ඒක හැබැයි open කරපු එකක්, it is filled with water. Water should be filled up to the level of the carbonated drink. එකම level එකට fill කරන්න ඕනේ. And close, we have to close the bottle of the lid. එහෙම close කළාට පස්සේ we have to take those both to the hand and we have to touch that. We have to check whether what is the bottle which is having more hardness. ඔහොම අපි අරගෙන check කරලා බැලුවොත් අපිට පේනවා the unopened soda bottle which was taken from the shop, it is very hard. ඒක හරි hard. හැබැයි අපි අර වතුර පුරවපු එක එහෙම hard නෑ. අන්න ඒකෙන් අපිට identify කරන්න පුළුවන් තව දෙයක් ඒකෙනුයි. And also when we are opening, the bubbles are formed with the same time, in the same time we will heard a sound like sh ගාලා. ලොකු අර sh ගාලා අර හුලං යන සද්දෙකුත් එක්ක ඇරෙනවා. එතකොට අපිට කියන්නේ අපිට pressure release වෙනවා. The pressure is releasing when we open a carbonated drink bottle. That means pressure, that's the effect of the pressure on the solubility of a gas. That means අර අපි water bottle එකේ pressurize කරලා නැහැනේ. We just open the bottle and fill it by using a tap and close the bottle. There's no pressurized air in it. ඒක හරි soft. හැබැයි ඒක පොඩ්ඩක් අර squeeze කරන්න පුළුවන්. හැබැයි soda water bottle which was taken from the shop, it is not that much soft and squeezable. It is very hard due to the pressure in it. So to dissolve carbon dioxide gas in a carbonated drink, that means fizzy drinks, that manufacturing process has high pressure and low temperature. What they do is they cool the solution, they dissolve carbon dioxide gas in cold drink. And also they are doing this in high pressure. ලොකු pressure එකකින් තමයි dissolve කරන්නේ. ඒකයි අපි open කරපු ගමන් අර ගාලා ඒ ටික යන්නේ. ඒ ගියාට පස්සේ bubble form වුණාට පස්සේ there's no. The bubbles are forming because a bubble form වෙන්නේ earlier there was some dissolved carbon dioxide in it. But now the previous pressure is not there when we are opening it. So carbon dioxide gas cannot be there. They want to be settled down. They want to be settled down with the, they want to be, make the pressure even to the atmospheric pressure. ඉතින් යාලා ඒක කරගන්න ඕන නිසා what they do is they release some dissolved carbon dioxide gas. Once they dissolve it, we can see bubbles. So with this experience, here you can see what is happening here is under normal conditions, as here, these things are, these bubbles which are here, CO2 is not dissolving in water well, only one water molecule, one carbon dioxide molecule is there. But when the temperature is dropped, temperature is decreasing, some of them, another few is going to be dissolved. And also, when the pressure is also increased, rest of the carbon dioxide molecules are dissolving in it and only one is there. So there may be some carbon dioxide in this area, that means in this area before the opening of the lid. in that way. These two factors, temperature and pressure, are affecting on the solubility of a gas. So, what will happen then when we increase the pressure? What will happen to the solubility of a gas when we increase the pressure? What will happen when we increase the pressure? What will happen to the solubility of a gas? Can you explain? Sydney, Hindi, can you? You know that? Okay, Sydney, tell me. What will happen to the mixture of gas and water? Actually, what will happen to the solubility of that gas when we are increasing the pressure? Can you tell me, Sydney?
And the solubility of gas increases.
Yeah, good. Solubility of gas is increasing. When we increase the pressure, you can see here P2 is higher than P1. So it is increasing the solubility of the gas. More water molecules, more gas molecules come to the water phase. ඉස්සෙල්ලට වඩා more water molecules come to the water phase. Then Hindi, tell me, can you explain what happened to the solubility of a gas when we increase the temperature?
Temperature decreases.
Yeah, the solubility of a gas decreases. Yeah, that is the thing. ඔයා solubility of a gas, it decreases කියලා නේද?
Yes.
Yes, that is the thing. අපි රත් කරනකොට, we can see here, these bubbles are not just formed from somewhere. මේ කොහෙන්වත් හැදිච්ච ඒවා නෙමෙයි. They were dissolved gas in this water sample. Once they are boiling it, they are releasing out. That means temperature, when the temperature is increasing, solubility of a gas is decreasing. When the pressure is increasing, solubility of a gas is increasing. That is the thing. So, is that clear to both of you? I hope that is clear to you.
Yes, teacher.
Okay. එහෙනම් ඔයාලට හෙට මේකේ කොපි එක ගන්න වෙනවා. හાર્ඩ් කොපි එක මම ටියුටෝරියල් එක අප්ලෝඩ් කරලා තියෙන්නේ. ඒකේ පිටු ටිකක් තියෙනවා. මොකද පිටු 10ක් විතර තියෙනවා. පැති 20ක් විතර තියෙනවා. මොකද ඒකේ අගට මම දාලා තියෙනවා අර එක්ස්ට්‍රැක්ෂන් මෙතඩ්ස් වල පොඩි ෂෝට් නෝට් එකක්. ඒක නිසා ඒක ටිකක් චුට්ටක් දිග වෙලා තියෙනවා. But this is a simple lesson, although it is very long, like a math. So you have to take a printout and come to the next lesson. So I'm going to stop here today because from here we have a new section, composition of a mixture. එහෙනම් මම අද මෙතනින් stop කරන්න හදන්නේ. ඔයාලට වෙබ්සයිට් එකට ඇවිල්ලා ඒ දේවල් වලට access කරන්න easy වෙයි at the end of the registration, and you will be able to download the tutorial then. Okay, Hindi, okay. Sydney, shall we stop now?
Okay, teacher. Thank you, teacher.
Okay, good night. You're welcome. Good
Good
night.
Good night, teacher.
Mm.